right, let's go. We're talking about Venn diagrams tonight, and it's going to look like you have a lot to write. You don't have to write down everything. I'll kind of show you what you need to write and what you don't. You definitely need to write the definition of a Venn diagram, visual representation of sets of items and the relationships between them. So we kind of talked about this already with, what do you call that? Deductive reasoning. But an always relationship or an if then relationship always has one circle completely nested in your second circle. Sometimes relationship has your two circles overlapping. So, for example, the set of boys in the classroom and the set of students who play an instrument. So, some boys play an instrument, so they would be in the overlap. Some are just boys, and some are just instrument players. Or you could have two sets that have nothing in common and they would have no overlap or anything that might be the set of, um, I don't know, 10-year-olds and 11-year-olds. Because if you're 10, you can't be 11 at the same time. Okay, so we see circles or we see relationships, and however many sets of items we have that many circles. So if you take a look, this is a representation of all of the houses on one street. Everything in the B circle is the set of all the blue houses. In the A circle are houses with antenna, and in the G circle are houses with a garden. So you can see in the very center here, we have the set of houses that are blue with an antenna and have a garden. This section right here are the houses that have an antenna and are blue. This section here are the houses that are blue and have a garden. And this section here are the houses that have an antenna and a garden. And then out here, you would have the items that are just houses with an antenna, just houses that are blue, just houses that have a garden. And this section, the 11, for example, are just houses that have an antenna and a garden but are not blue. This section has an antenna and are blue but doesn't have a garden, and this section would have a garden and are blue but not an antenna. And then this set are houses on the street that don't have any of those items. So the question that I want you guys to try to figure out by tomorrow is how many houses are on the street total and how many of those houses are blue? See if you can figure that out. This is another example. It's a little bit simpler. Now we have a group of 30 girls, 18 play field hockey, 14 play soccer, and 5 play neither. So the question is how many play both? So I'd like you to create a Venn diagram here of field hockey players and soccer players and see if you can figure that out based on your Venn diagram. Okay, and the last thing we need to talk about with Venn diagrams, and I'm really, really sorry, these were not, well, I'll get to that. Okay, so when we talk about sets of items, there are some items that are in both sets or all the sets, some that are only in one of the sets, for example. So the joining or the inclusion of these sets are referred to as either the intersection or the union. Intersection is represented with this upside down U, and we use the word and, meaning that I want a number that is in both set A and B at the same time. So in this case, it would only be the overlap. So when we talk about and, we mean only the overlap of the two sets. So 1, 7, and 13 in this case. When we talk about union, we're saying that it could be in set A or set B. So that means we'll take anything in either set. So union includes everything in both, whereas intersection only includes the overlap. All right, and finally, we're going to talk about algebraic proof. You do not need to copy these down. These are already included on your notes. However, these do need to be memorized. We will be using these to prove why an equation is solved the way it is. So we're given an equation and we need to prove that the answer is true. To do that, we're going to set up two columns. Okay. In the first column, we're going to solve our equation, but in the second column, we're going to write why. That's called the justification column. So whenever we prove something, we need to say why. Just like in English, when you say something, you need to say why you say that. So in this case, the first step we're going to do is distribute that -5. So we call that the y would be the distributive property. We replace it or substitute it with what we get after we distribute, or negative 5x minus 20. So do you see how we're going to use the properties up here to justify or tell why we're allowed to solve the equation the way we are? Then we're going to add 20 to both sides to get rid of the minus 20. And we do it on both sides, and that's called the addition property of equality. We substitute again for what it's equal to. The 70 plus the 20 gave us the 90. And here we were left with the negative 5x. And then we divide on both sides, again, the division property of equality, and then we substitute for what it's equal to. So we're left with the x over here and negative 18 here. So our first step is always going to be what we're trying to prove, and we're going to go through the steps of solving until we get to our answer, or what they wanted us to prove or end up with. All right, I'm sorry that these notes were a little bit longer, and I'll see you guys